Good evening, everyone. Um so today we are back with the eighth session in a problem solving session, and in this session we will talk about paints and plastics. And I, Purvika, will be presenting you all with this particular problem solving session. So we have been doing this particular session for the past 7 weeks, and this is our eighth week and the last week also. So, just as we have done in our previous sessions, today's session is also about one particular module, that is the last module that we are talking of. And here also we have some questions which are designed mostly to cover up the doubts, if any doubts you have in your as a graded assignment, and from the overall module video lectures that we have seen. So basically, if we look at week 8, what did we learn from there? So the first lecture, that is lecture 36, was about paints. The next was also about paints. In fact, the next two lectures, like there were total three lectures which was about paints. So in the first lecture it was mostly about the introductory, like why paint is needed, and what are the different constituents of compositions of paint. And later on we saw what are the different types of paints, and how we can use different types of paints in different surfaces, what are the different defects of paint, what are the different application process of paints. So all these things were discussed in details in our this lecture 37, 38. And then lecture 39, or the fourth video of eighth module, was about plastics. And the last lecture was also about plastics. So in plastics also, the first was about basic introductory towards where we can use plastics. And lecture 40 was mostly about what are the different types of plastics and what are the specific uses. So this was about the overall content of this particular week. So today's what will we see in today's particular question, this live session? It's about theoretical questions as well as some of the pictorial questions that we mostly keep. It will be at the end. So here comes our first question, which is, how thick or thin is the layer or film of a paint? So I would expect you all to answer this one. Yes, any answers from you all? Yeah, it's quite a straightforward question, which where the answer is 60 to 150 micron is generally the thickness of paint. And when we read about paint, we also saw that there will be a minimum of 2 or 3 coats. These are required in order to fully cover the surface. And also when we talk about 1 liter of paint, then it mostly covers something around 10 to 15 square meter. Okay, and also if it also depends upon what type of paint we are using and what kind of coverage we are going to. 10 to 12, not mostly, it's mostly 10 to 12 square meter, not 50. So it also depends upon what kind of paint we are using, and accordingly the coverage is dependent upon that as well. Okay, so these are some of the very basic things that we had we learned in our video lectures. Now coming to the second question. So the second question is basically about creating the understanding of the different composition of paint, as well as understanding how paint it can be applied. So this particular constituents or the composition of paints help you to understand how things can be, how paint is basically applied, how things happen. So I'll just discuss quickly about those. But yes, before that, I got one answer from Harsha. She's saying option A. Basically, you have to match base, thinner, pigment, and binder. And as we all know, these are the components of any paint. And okay, since I'm not getting any more answers, I'll check. Yes, it's absolutely correct. So base is basically the body of the paint. And then we have there can be thinners. So thinner is basically mixed to get the desired consistency in order to work in order to increase the workability. And then there are pigments. So pigments are basically the coloring agents which are in the form of powdered minerals or organic substances which are added to get a particular color, the desired color that we want. And of course, there is binder, which is again another important component, which basically binds the base or the principle to form a continuous hard film. So these are not the self-explanatory, but yes, we have learned about it. Now coming to our third question, which says that adulterant added to paints to increase its bulk volume without affecting its useful properties is known as, is it base, is it binder, is it additives, or is it thinner? Yes, any answer? Okay, I got one answer. Just be careful about this particular word, adulterant. Okay, although Harsha says option B, let's see the answer. It's basically additives. Okay, so additives are basically the adulterants which are added to the paints in order to increase its bulk volume. However, we are not altering the useful properties of the paint. So if we look at the different components of the paint, which we have already, like we have started discussing about it with the help of the two questions that we have. So if you look into the paint components, so basically you have got one base and another important is the vehicle. So these two, base and vehicle, this is the primary these are the rather the primary components or of paint. Again, when we talk about paint, we have already discussed it's basically the principle of the tri component, okay, which is held in suspension. Then there is something called vehicle that I am talking about. So vehicle is basically, just a second. Yeah. Vehicle is basically made up of, it comprises of rather binder and the thinner. So these are the two things that the vehicle is composed of. And now when it comes to binder, so binder is a very important, once again it's a very important component that helps in binding the base, that is binding the principle and the pigments. Now again, what are the pigments? So these are again the coloring substances which we can get by adding any mineral powder or any organic substances. So binder helps to, you know uh, and keep the base and base that comprises of principle and the pigments together in order to form a continuous hard film. So this is what binder is. Now coming to thinner, thinner is generally, it is added to get the desired consistency. Basically it increases the workability. That is what we have again seen in our previous second question. And now coming to this additive. So additive is the adulterant. This is something which is, which is added in order to increase the bulk volume without affecting its useful properties. Some of the examples of these additives are this chalk, gypsum, or even barium sulfate, silica, magnesium silicate. All these things can be used as an additive. And apart from that, there is also dryer or plasticizer used, which helps in the oxidation process of condensation or oxidation or the condensation process of the vehicle. Okay, so that is what the use of dryer or plasticizers are. So I hope the components, the different components and the different uses of the different, or rather the properties of each of the components are clearer to you all. Okay. Now coming to my next question. So next question is about, now the question is about the ratio of the volume of the pigment divided by the volume of both pigment and binder together is called. So by now you all know what is pigment, you all know what is binder. Okay. So now you all have to to just answer that what is this ratio known as. Okay, I got one answer, that is okay. Balu also says option C. Any more answer from anybody else? This is of course the correct answer. It's basically the PVC or the pigment volume concentration. This PVC is not the same PVC as we will or the polyvinyl chlorides that we talk about. This PVC about paints is basically the pigment volume concentration. We have also learned another PVC, UPVC, but that is different. That is in plastics. Okay, so don't get confused with the two terms. If there are questions related to with using the short form PVC, please be careful and understand that what context, in which context the question is being asked. Okay, and then just remain calm and composed and give your answer. So when we talk about this PVC or basically pigment volume concentration, so you can see from here, from the particular slide only, you can see that it is basically the ratio of the volume of the pigment divided by the pigment volume and the binder volume. So this is what PVC is all about. So if you look into this particular image as well, you'll see in the x-axis we have pigment volume content, that is what percentage of PVC is there, and here we are talking about the the different properties like blistering or gloss or I mean the glossiness that you'll get, or the kind of permeability or the kind of rusting you'll get when applied. The particular paint, and if you see, this is the particular paint medium where we can see the increase, like if you look into this side, you have more binders in this side, whereas if you look into this particular more pigments to this side, whereas if you look into this is much more dispersed, okay, kind of paint. So there is this particular consistency, okay, there's this particular consistency which is known as the critical consistency, or rather we call it as CPVC or critical pigment volume concentration. So it is that particular volume where the binders, it should have it should have sufficient binders to fill in the voids between this pigment particles. So these are the pigment particles and the binders should be sufficient enough. So that particular range or that particular value is known as CPVC, which is here, it is marked over here as something as 55 percentage. It's something around that range. So this is basically CPVC, and according to the what content or what percentage of PVC is there, it will make a particular surface glossy or lesser glossy, okay, or rather less glossier, however you want to say it. So if we see that increasing the PVC, it reduces the gloss and makes the paint very flat, which is around a range of 50 to 75% of PVC. So do we see that? Yes. If we look into this particular, if you see this particular curve, so this is basically the curve which is representing the gloss. The type of gloss you'll get by applying the paint. And if you see here, it is giving the most glossier. So glossier, we see decreasing the PVC has more of binder and is glossier, which is around 25 to 30%. Yes, if we look into, if you draw the line, it ranges something around this range only, this particular range. And if you see that the percentage of PVC is around 25 to 30%, then of course we have more glossier kind of a paint. Whereas if we reduce the PVC or this pigment volume concentration, then what happens, the glossiness of that particular paint reduces. So I hope this particular graph will help you to remember and not get confused, like what will happen if the percentage of PVC reduces, or what will happen if the percentage of PVC increases. So if the percentage of PVC is reduced, we get more glossy surfaces, okay. And what else did we learn from the CPVC? So we also learned about how to find out the critical value. I mean, how to find out the CPVC, and accordingly we use this particular formula: 1 by 1 plus oil absorption into rho by 93.5. So this is basically, we have written it in English P, but this is basically rho, which represents the density. Okay, the Greek letter. So don't get worried about this particular, you know, in the video lectures ma'am has told rho and this. So I hope you all remember this one. So this is basically the density of the pigment in gram per cc. And this oil absorption, this particular value, here it is given as you will get this particular value OA, or oil absorption. It ranges, it should be below 25. And here the rho is also given. So if this particular thing is given, we know how to find CPVC. So CPVC is basically equal to 1 by 1 plus 20 into, we have rho as 4.2 by 93.5, right? So this is giving us the value of, I'll do with you all, and even if you all want to do, like, it would be great. So we are getting the value as, yes, we are getting 1 by 1 plus 0.8983. So it depends upon where you want to round off this particular value. Okay, so you are getting that is equal to 1 by 89839. So we get the answer as 0.5267. So if you convert it into percentage, so you multiply with 100 to convert it into percentage, and that is equal to 52.67 percentage. So this is how we basically calculate the CPVC value. Okay. So this was the answer. So it's basically 0.5269. So 69, and we have got 67 in, is basically because of the round off, where we are rounding off the value. Other than that, this is how we calculate it. And also remember one thing, that PVC value is below the CPVC. Only then a solution qualifies to be called a paint. So this is a very important statement, or rather a very important thing that you need to remember. I think you will be easily able to understand once you just refer to the graph that I have shown in the previous chart. So this is how, just a second. Yeah. So this basically, I hope this particular chart shows you. So this, if this is the CPVC value, so this particular side is qualifying as paint, right? So this is what paint is, and this is not the paint side. What? Okay. So that was all about CPVC that we learned in our video lecture. Now coming to our next question, that is, which is a very, once again, a very straightforward question. It has nothing much. It is asking about which of the following statements are correct regarding paint. So first one is about protects all surfaces against organic growths, termites, fungal attacks like wood or brick, provides aesthetic value or identity with the building surface, applied both interior or exterior, increases the surface durability, and also can give fire protection. And the last option is does not modify light reflection or heat radiation of a surface. So these are the four options you have, and accordingly, or the rather the four statements you have, and accordingly you have four options to select which of the correct, which of the following is correct. Okay, I got one answer, that is PQR. Any more answer from anybody else? Okay, Gaurav Chit also says A. Balu says A. Okay, this is, yes, like nothing much to exaggerate about. So yes, it's absolutely PQR, and also it depends upon the color of the light, or the type of sorry, not the color of the light, the rather the color of the paint, and the type of paint that you are using. And lighter the paint color is, the more will be the light reflection. So of course, this particular color of paint is very important, or rather paint plays a very important role in the light reflection or the heat radiation of a surface. And accordingly, I think you all are aware about this hot and the houses in Rajasthan, for example, Jodhpur, Jaipur, where they use a particular light shaded these paints. And also Udaipur has got this white painted houses. So all this somewhat affects that how much of light is getting reflected, because there we know that during daytime it's very hot, and obviously no one would like to get the heat get absorbed in their from the walls and get much more the interior gets much more heated up. Nobody will want that. So keeping all these things in mind, also the color of the colors are used, and light shaded colors are used in order to uh, enhance the light reflection. Okay, so that was quite a simple question. Now coming to the sixth question. Once again, sixth question is also a very simple one, where you just need to say what is the sequence of manufacturing paint. So the first option or the first statement is about mixing the ingredients, basic ingredients. The next is about grinding the ingredients into required fineness. Then it's about adding thinners, and that is adding solvents. And the fourth statement is agitating the mix. Okay, I got one answer, PQRS. Oh, yeah, basically that's the correct answer. PQRS. So these statements are given in that order only. But yes, apart from this, there's also another thing. Yes, absolutely correct, Harsha. There's also another thing that we need to remember is that the last step is basically packaging on order, and also we need to remember that this mix is basically agitated. Uh, just a second. Sorry. So this mix is basically agitated in order to avoid any kind of segregation, and only when there is this order coming, then this particular quantity of this paint is basically packaged. So this is the simple steps about manufacturing or the simplified steps of manufacturing paint. Okay. Now coming to our seventh question. So what does this seventh question talks of? It says that there are different types of paints. There is a distemper, there are PU, there are melanin, PU and melanin rather. I have put it in one party, but they are two distinct types of paints. Then there are cement paint and premier enamel. And where are these particular paints applied? You will have to understand that. Okay, I already got one answer, which is saying, okay, Harsha, Balu, both of them says D. Any more? Yes, absolutely correct. The option D. So distemper is basically used for painting the interior surfaces. PU and melanin, they are two distinct types of paints. I'll discuss about them in a very in a nutshell. But yes, they are used over the wood surfaces. Cement paint is something which is used over the exterior surface. And there's this premier enamel or enamel based paints or enamel paints. They are basically used over metal surfaces. So coming to distemper paint, so distemper paint, if you look at the basic constituent of this distemper paint, it's basically chalk, lime, and water. And this type of paints are also known as cement paints, because due to the presence of this particular lime. However, the cement paint, if you talk about the cement paint which are applied on the outside surface, or rather the exterior surfaces, cement paints exactly has got it has got some more other constituents. So distemper paint may be known as it is often synonymously called cement paint. However, the cement paint which we are talking of and it is applied in the exterior, I'll show you what are the different constituents. So this particular paint can be applied directly on the cement walls, and you can use a primer. It depends, like you may or may not use a primer. However, we have learned what is priming, or putting a primer is basically the initial coat that is applied on the walls to give a better finish, or in order to reduce the quantity of this distempers. So that is what primer is all about. And when we talk about distemper paint, it's important that we remember that it's water based paint. However, there are other different types of distempers as well. For example, there can be dry distemper, which is available dry and it needs to be mixed with glue and water. There is acrylic distemper. So this acrylic distemper has got, basically from the name itself we can understand that it has got this acrylic copolymer formulation. Okay, there can be synthetic distemper or oil bound distemper as well. And this particular paint, it includes the drying oils and it increases the coverage area. So even in distemper paints, we'll find numerous types of distemper paints, and also the different painting of this paint companies. They have got a wide range of there's not just one distemper paint. There can be several segments in this particular distemper paint itself, each having its own maybe the basic constituents are same. However, there are changes in the way it's changes in some of the components, and maybe there are changes in how it is what are the components. And maybe like if you look into this acrylic distemper or the oil bound distemper, the basic difference that you have is that one has got this acrylic formulation, whereas other one is having drying ones. So these are some of the certain changes that are there, and according to the client's preference this can be used, or according to the place where you are basically painting it. Even in interior surfaces, we know that there are kitchen, there are living and dining room, there are bedroom. So kitchen always has got a very different kind of particularly in Indian scenario, this kitchen has got a very different kind of uh, not, I won't say I mean it's not about different kind of use I'm telling, but yes, the kind of culture that Indians have. We always need something which can be where the walls can be washed, or the any kind of stains can be removed very easily. So keeping all these things in mind, basically the paints are chosen, even if it's for interior surface. Okay. Then, as I was talking about this not melanin, sorry, it's melamine paint or the PU paint. So these two are basically, different types of paint. When it comes to melamine paint, melamine is basically an organic compound which is, it's hazardous. However, it is combined with formaldehyde, and this melamine resin is produced, and which is safe and which is not toxic. And this particular melamine polish can be used over furniture surfaces. Okay. And this particular resin is it's a very stable component, or rather a stable compound, and it is heat tolerant. So melamine is basically used to close the pores on the wooden surfaces, and it makes the particular wood non-breathable, so that it can stay stay in that particular form for a longer time, because we know wood is a it's an organic substance, and how it can decay, or how it can get affected by termites and all this different other fungal attack and all these things we have already read. So it's very important that we coat our wooden surfaces as well, and melamine paint is one such compound which can be used, and which can basically protect the wood from hot and cold objects placed on it, and also from any kind of minor damages. The other one is PU polish or PU paint. So PU, the word PU, we have already come across this particular term previously also. So PU is basically polyurethane polish. So this PU polish is again a polymer that is applied in order to create a protective coating over this wooden surfaces, and it also helps to protect the surface from any kind of corrosion, abrasion, weathering, and any kind of degradation that happens on wooden furnitures over time. And this PU polish can be both this water based and solvent based, and both this type, this PU, either the water based or the solvent based, whichever you use, but it gives a wide range of finishes from matte to satin to glossy. So even there are preferences of clients, that some people want matte finish, some people want glossy finish. So you can always, even from one particular paint like PU paint or PU polish, you can also give clients different options, like how their furnitures would look like, and they can select from there. And then coming to the cement paint is basically, it's mostly applied in the exterior surface, but also, sometimes cement paint can be used in interior. But yes, mostly we see, this particular cement paint is being used outside, because it has a very important property, where it basically prevents any kind of water penetration, and also, reductions of dirt collections. So this is something which is very important to provide in the outer surface, right? So that is why cement paint is very, it's a very well known and well used paint on the exterior surface. And if you look at the composition, you'll find that there's this presence of white or Portland cement, almost 50 to 60%. There's also lime, there's also calcite or titanium dioxide, and there are different other, pigments, alkali resistant pigments as well. So this is what cement paint is all about. So we had, so these are some of the, like, these are the discussions which we had in our question. But even apart from this, we have also seen in the interior surfaces we can use another thing that is known as plastic emulsion, right? You can also go through this is used in interior surfaces as well. Okay, so for the metal surfaces, we can also use not just premier enamel, we can use synthetic enamel. So basically, any kind of enamel. Again, if you look at, this enamel, this is what enamel paint is about. So this enamel paint is basically an oil-based paint, and enamel is a very good option for its durability. Now, very interestingly, it's applied on metals, mostly ferrous metals and non-ferrous metals that are used in our building industry, for example, aluminium. Until and unless you don't want to give it a particular color, we generally don't need any kind of, coating of paint on it. But if you talk about the different like the metals, they definitely need this particular, layer of paint, because otherwise, it's this corrosion and rusting is going to happen. So metal is, first of all, it's metal itself is a very durable, element, or rather material. And on top of this, if we have this enamel painting is again a very good, kind of paint, which has got, high durability. So if you put metal, enamel paint over metal, it is going to last very long. The durability increases by manifolds. So that is also one of the reason why, this enamel paints are applied on top of metal works, because it acts as a very good substrate for this enamel paints. Okay, and that is what this enamel paint is all about. Apart from this, we can also use any generic enamels also. Like, this is what enamel can be, this generic general purpose enamel. It can be premier, and it can be synthetic as well. Okay, so these are some of the types of paint. And apart from this, for when we talked about this exterior surface, we can also use acrylic emulsions and textured plastics, right? So these are also some of the options that we have while we are selecting our paints. I hope this thing is clear to you all. And that brings us to our next question, that is the eighth question, which says that match the following components used in painting, used in or after or before, however, like in the process of painting, rather, in the process of painting with their respective uses. So, what are the things that we have? We have varnish, we have zinc sulfate, we have paraffin, and also we have sodium bicarbonate. So, these are some of the components or compounds that we have, and accordingly, you have to match. Okay, I got two answers. Option C. Okay, yes, absolutely correct. So, this particular, components or rather compounds, it comes. Why am I talking about this particular, this compounds? It's because it's also important that when we are applying paint on any particular surface, we have we can't just go and just take a brush, dip on the paint and just color it. We can't do that. So in order to paint also, we need to, or in order to apply the paints, we also need to prepare the surface. Okay, so it depends upon what kind of material has been used on, or on what you are going to paint. So if it's a plastered or a concrete wall, and if it's a new surface, you have got, you have to understand whether there is dampness or not, and accordingly, if there is a dampness, on that particular surface, because it's a newly constructed wall, so then you need to provide a, apply this particular benzoline resin, and there's another thing that is known as, here we have the question, so this paraffin. So all these things are basically mixed in the ratio of 5 is to 4 is to 3, and then they are applied on the surface. Again, you have to understand that whether the surface where you are going to paint, whether it's an old surface and there was already some kind of paint layer on it or not, then what will you do? You'll go and try to scrub the old paint. You'll try to remove it, and you'll also try to detect whether there are any kind of efflorescence or any kind of chalking that has happened, and accordingly you will clean out the surface, and then you will put a new layer on top, new paint layer on top of it. So that is why, this particular this particular compounds, they are so important for you to understand that you may not get always, the same kind of surface to paint upon, and you just can't buy something from the market, a type of paint that you've learned, and just apply. So you need to go through a series of process. Maybe you will not do it on your own, maybe there will be skilled laborers will be doing it, but you as an architect, or you as an engineer, or you as a person from the building industry, need to be aware that whether that person, that the person who is basically supposed to paint, is doing the things in the correct order. That is why we all need to remember, or we need to learn all these things. So let's just look into the answer once, and the first option that we have is varnish. So varnish is basically used in wooden finishing applications, where you want to get that wooden texture visible. You don't want to coat it with something else and look like a just a painted body. You want to have the grains and the fibers visible in a like the way it is. However, you want to put a protective layer on top of it as well. Then we use varnish. Then there's this zinc sulfate. So zinc sulfate is applied in wet weather condition to free off the alkalis on the wall surface. Then we use paraffins. Paraffins are applied on fresh, or rather new cement or concrete walls, so that basically on the damp surface, along with this benzoline and resin, and in a particular ratio that we have to follow. And then there's this sodium bicarbonate. So sodium bicarbonate is used to remove any kind of grease from the metal surfaces. We also use sodium hydroxide as well. Okay, so it's basically either petroleum or any kind of alkaline solutions like sodium bicarbonate or sodium hydroxide. So this particular removal of grease, it can be removed using the other types of compounds as well. So apart from this, we have also learned that how we can paint on new wood surface, how we can paint on old wood surface, I mean how we can apply, then we need to again clean off any kind of presence of any old paints of when we are painting on wood surface. And this greasy or oily surfaces needs to be washed off with some soapy water. So these are something, this is these are some of the way that we apply the paints. Okay, now coming to our ninth question, which by now we have almost covered the maximum of paints. And now we have come to the question of plastics. So which match the following types of plastics with their respective subtypes. That is what I have given. And we have thermoplast, we have thermosets, we have elastomers. So these are the three types, and you have to just match with your, yes, any answer. No answer. Okay, I got one. Hmm. Okay. So okay, did I do any mistake? Uh, Thermoplasts. I I just hope the answer that I have put is correct, because let me just the check whether go through the options that I have put, and maybe then I'll once again come back to yours. So R4 is like everybody is sure about this, because elastomers are, this EPTMs are a type of elastomers only. The only doubt is about epoxy resins. So epoxy resins are basically thermosets. So this will be Q1. Okay. So the remaining thermoplasts, one is the vinyl, and then we have phenolic resins. So phenolic resins, once again, epoxy resins and phenolic resins are uh, thermosets only. Okay, so thermosets, we have option 1 and option 3 to be thermosets, and thermoplasts are basically vinyls, and elastomers are EPTM. So just okay. So just try to remember as much as possible. I hope it's a very easy way you can remember, as at least that is how I do. So basically, when it talks about this phenyl resins, or polyester resins, or not phenyl, sorry, phenolic resins, or polyester resins, or epoxy resins. So any resins, whenever it comes, it mostly it's under the thermoset category. Apart from that, urea formaldehyde is also in the thermoset category, or melamine formaldehyde is also in the thermoset category. Whereas when we talk about thermoplasts, so thermoplast have this this polyethylene, then polypropylene, then this particular vinyls are also there, but yeah, acrylic is also there, then polyamides are there, then polycarbonates are there. So from this particular polycarbonates, fluoropolymer, polyamides, then vinyl, so these basically falls under the thermoplast category. And if we look into the elastomer, from the name itself, I think you'll be able to understand, it's basically the rubber materials, or the neoprene, or EPDMs, or butyl rubber. All these things falls under the category of elastomers. Okay, so try to remember this in this particular way. Maybe it will be easier for you all. So just once again, this particular thermoplastics, and or rather thermoplasts and thermosets, they have been discussed in details in the video lectures. I just give a very it's a very brief recapitulation of the thing. So thermoplasts, they are basically they are having this low melting points, generally at around this 50 degrees Celsius, and that is why they can be remolded or recycled very easily. Okay, and the very wide range of applications of these thermoplasts include any rope, carpets, or reusable plastic containers, or car batteries. Anything that can be reused are falling under the category of thermoplastic, primarily because of their low melting point, which is something around 50 degrees Celsius. Whereas on the other hand, these thermosets, they are harder ones, okay, and they can withstand high temperature, and they have melting point something around 177 degrees Celsius. And once they harden, they cannot be reformed, and as a matter of fact, they cannot be recycled. Okay, for example, circuit breakers, for example, cell tower tops, or heat shields, or disc brake pistons, all these things are made of this thermoset plastics. Okay, and then coming to elastomers. So from these images, I think you'll be able to understand this. Elastomers are basically elastic polymers, okay, or elastomers, and they are the kind of the molecules, the way they are arranged. It makes them, or it rather gives them this particular property. And the elastomers are widely used for making rubber tires, rubber tubes, for these motorcycles, bicycles, or for making belts, hose, gloves, gaskets, and all these things. So these are the very common uses of this elastomers. Okay, now coming to our 10th question, which is the type of plastic with lowest coefficient of friction of any known solid material is. Any answer? Okay, any answer? Answer will be PTFE. Okay. Now, what is so in this particular question, you'll see there are ETFE, PTFE, PMMA, and CPVC. So these are all the short forms that I have used. I'll just quickly explain you all what are this ETFE, PTFE, and PMMA or CPVC. So ETFE is basically ethylene tetrafluoroethylene, or it's basically known as ETFE. Like the short form is used often, and it's a fluorochloric polymer, or rather of, or you can also, but I mean, if you just break what is fluoropolymer, this fluorine based plastic. Okay, so that's what a fluoropolymer is all about. When we talk about PTFE, PTFE is also a fluoropolymer, or or its full form is polytetrafluoroethylene. PTFE, it's also a synthetic fluoropolymer. However, if you look at the properties of ETFE and PTFE, they are a bit different. And also, when we talk about ETFE, it's one of the, of course, it's one of the most durable fluoropolymer coating, and it is widely used as a coating over this different industry. It's used as an industrial coating over different materials as well. And when we talk about PTFE or polytetrafluoroethylene, you can also refer to the slides of the videos, where you will find the details about the the physical properties as well. So this PTFE is again a very high density and it's very much resistant to high temperatures, and it's also one of the very versatile material which is used. And we all know this non-stick application. So PTFE is that particular material which is used over non-stick pans and cooking pans. And there's also this a brand name which is known as Teflon. Maybe you all have heard about people saying Teflon is used, Teflon is used. Teflon is nothing but this particular, it's the brand name of this particular PTFE or polytetrafluoroethylene. And okay. So next we have PMMA. PMMA is basically polymethyl methacrylate, and this is in short form we call it PMMA. And there are different other names. We call it acrylic. We call it plexiglass as well. Okay. And this particular, this is also a synthetic polymer which is very light in weight, and also it's very economical to use, especially in places where we do not need any kind of high strength things. Okay, there you can easily use it. and you can use it as a instead of glass. Okay, because of its properties, it's quite transparent and it's also rigid. So these two properties makes it a very useful material to be used instead of glasses, and you can use it as shutterproof windows, or illuminated signs, or in skylights and aircraft canopies. And there's this UPVC. So UPVC is basically unplasticized polyvinyl chloride, or we know about PVC, that is a vinyl chloride, PVC, or polyvinyl chloride. So there's this UPVC, which is unplasticized one, and this is very very commonly used in windows and doors. Now, what is the basic difference? Like, why can't we use PVC for doors and windows, and why can we use UPVC for doors and windows? So the basic thing is that PVC is flexible in nature, and that is why it's not possible that you make window frames from PVC. However, UPVC has got its rigidity, and as a matter of fact, UPVCs can be used as door or window frames, and also UPVC is much more durable when compared to this PVC. Other thing is that it's said that PVC has got one particular, this toxic products like this BPA, or the phthalates are there. So these phthalates and BPA, these are very much toxic in nature. However, when it's unplasticized or UPVC is more into the environment friendly side. So that is why UPVCs are often preferred in comparison to the PVCs. Okay, so these are what are PVC, UPVC, PMMA, and ETFE and PTFE all about. Okay, so now we have our 11th question, which is, which of the following are characteristics of polycarbonates? So polycarbonates is again another type of plastic. So it says statement P is about it has got very high impact strength 200 times of glass, does not scratch easily, superior clarity, has poor UV resistance in its natural form than acrylic. Okay. So PRS. Yes, absolutely correct, Rashmi Balu. It's option B. Basically, polycarbonates, they get scratched very easily. That is one of the, let's say, disadvantage or drawback of these polycarbonates. And not only that, these polycarbonates are basically polymers which have organic functional groups linked together by this carbonate group. So that's the chemical composition about this polycarbonates. Apart from this, coming to the usage in the building industries, it's a very tough and transparent plastic material that has got very good strength, stiffness, and also it's impact resistant even at low temperature. So you can see this particular image where this polycarbonate sheets have been used. However, if we talk about polycarbonates, one, of course, it gets is scratched very easily, and also it has got poor UV resistance in its natural form in comparison to the acrylic. So these are some of the you know drawbacks of using polycarbonates. Okay. Okay. Now coming to our last question, that is match the following with their uses, where one side we have thermocol or polystyrene, we have polyethylenes, we have neoprene, and we have silicones, and the other side we have the different uses. So neoprene, I think you all have already heard this particular name previously also, like of course you know others also, but we talked about elastomers, where I said that okay, I got answers. Yes, absolutely correct. So let me start from P only. So thermocol, yeah. So thermocol is basically used in used as building insulation materials. We know, like polystyrene, we have already talked about it when we were studying our previous modules as well. I think I've shown you some of the images as well. So polystyrene. And then polyethylenes. Polyethylenes are basically used in water tanks, pipe fittings, or joints. Neoprene, as I said, it's an elastomer, and it's used in gaskets for water sealing, thermal sealing, and silicons are used in sealants and adhesives. Okay, so these are some of the very common uses of all these compounds. So that brings an end to the different questions that we had. And let us see some of these very well known structures that have used plastic. And of course, we know that plastic is a very generic name of this polymers. And we see, let's see. So, anyone recognize this particular structure? It's a very, very well known structure, and I'll tell you where this particular, kind of plastic has been used. Yes, no one? It's the Millennium Dome in London. Architect Richard Rogers, and like what's more important for us is it's this PTFE or polytetrafluoroethylene coated glass fiber fabric panels that have been used on this particular dome. Okay, so that is how it's a non-structural thing, because the structural thing has been provided by this this cables and this posts. Yeah, it's in UK. And however, the cover, if you see, so it's basically it has used PTFE coated glass fiber fabric panels. Okay. Okay, next one. So this is the Yejipu railway station in China, and this has also used this ETFE cushions tensile roof. So this is basically the tensile roof, and this ETFE cushions have been used. So ETFE cushion tensile roof membrane structure. So this entire structure is what it is known as. So ETFE is, again, we have already learnt about ETFE, what this ETFE is, and that has been used to cover this particular. If also, I'll suggest you all to look, these are the images from outside. You all can get a look from, how it looks from inside, and you will be very surprised to see it looks mostly like, they have used glass only. It's so much, it allows the penetration of sunlight, and it looks so beautiful from inside as well. And you can always go back and look into the images, and you'll find it very interesting, I hope. Okay, so this is again a very well-known structure. mm, yes, anybody? No guesses? So this is basically a Denver International Airport, and this Denver International Airport, it has got this Teflon coated fiberglass roof. So Teflon, by now you know, it's basically nothing but ETFE only, and this ETFE is basically, this, it is coated on over the fiberglass, and that's what how the roofs are basically made. And this one, I think this was a bit discussed in the video lectures as well. Apart from this, we have also seen the use of glass fiber reinforced plastics in Hyder Aliyev Center in Baku. We have also seen the Beijing Aquatic Center, where ETFE has been used, and this is again another example. This is an example of the pneumatic structures. This is the Eden project in UK. This is by this architect is Grimshaw architect, and the cladding panels that you see over here are basically triple layered pillows of high performance ETFE foil, and they are environmentally efficient. So that is what this is the Eden project, and this is how you get a closer look. You can also get images which have much more closer images, or rather images from inside the building. So you can always go and check. And this is an example of a pneumatic structure. It's a wonderful example as well. So that brings an end to our today's problem solving session. So if any one of you have any question, we can discuss. Okay. So thank you for joining. And today was basically the last session of this particular run. I hope you all have gained something from this particular sessions that we try to conduct. And I'm not sure, but there might be one revision session as well, which we are not sure about it. And if there are any revision session, you all will be informed about it. So take a I mean, I would also again request you all, if you all find it helpful, do come back for the revision session as well. Okay, so thank you all for joining. Thank you, Harsha, for being a constant, I know, student in this particular sessions. Also Balu, Marvin, Rashmi, I remember, like, you all have joined most of the sessions. And thank you so much. Thank you, everybody.